All right. I know everyone's here. Everyone's ready. You ready? You ready? Class.
Yes.
Thank you. I forgot to check sound. I know. There we go. All right, sound works. All right, so we did the quotient rule yesterday. So differentiate the quotient of two functions. The corollary, that's actually a math term, corollary derivative of the reciprocal of a function. If a function g is differentiable, so that means I can take a derivative, okay, then the derivative of 1 over g is basically just going to come out to negative g prime over g squared. That's it. So we're taking the derivative of the reciprocal. Okay, that means I just flip it over, right? Yeah, 1 over that. So basically, if I want the derivative of this, negative g prime over g squared. Yes, no, maybe? So if you were here paying attention yesterday, you notice what we do on the side. On the left, I would label my function, I would label my f and my f prime, I would label my g and my g prime before I did any of the math. And that's what I'm going to do now. So, same thing right here. So if we had this, so we said this right here, 1 over, and doing the math on it, I have derivative of g, which is going to give me 2x plus 1 over g squared right here. So that's how we use it. And then the derivative of e to the x, same thing. So if we do this one right here, we start off with this, so the derivative of e to the negative x, it is actually 1 over e to the x. Go all the way around, and we come up with this again. Because we know the derivative of e to the x is e to the x. So the e is one of these that you really need to pay attention to. So right here we would have derivative of e to the x, which is here. On top, derivative of e to the x over e to the x squared. And then there's my negative sign right here, but because we have e to the x's, I can reduce mine. So this is a very good note to use for later. So you could actually just be like, oh yeah, it's right there. I know e to the x is something when I have this. All right. Now, I'm going to use the power rule for this. Okay? This is called that voodoo magic. So, what's the exponent on this first one? Negative 1, right? So what am I going to do with that negative 1? No. What do I do with the negative 1? Always. I multiply by the front, right? What's in the front? 1. So that's going to give me negative 1 x, right, times x. And what do I do to my power? Minus 1. But right now it's negative 1.
So negative 2.
Negative 2. Now, that's perfect. That's good. But now I'm going to clean it up. Because a lot of times you don't want to have negative exponents. What are you going to do to the negative exponent to make it positive? No. Got to make it positive. Nope. It's negative right here, but if I move it across the divisor, it's going to make it a positive. So right here it's negative, so this will turn into, if I do it like this, move it across the divisor, so now it's going to move to the denominator, and when it moves to the denominator, that's going to make it a negative, or negate that, so it's going to change the sign, so that's going to be a positive now, down here, x squared. And what's still left on top? Negative 1. So this is using that voodoo magic. Now I'm going to rewrite this one here. I'm going to rewrite this one knowing that it's 1 over u squared. So I'm going to rewrite it so I could just use the regular power rule on this. So that would just become u to the, rewrite this,
U to the negative.
-2. Because I want it up in the numerator. I want it all in the numerator to do the voodoo magic.
Okay.
So now it's there. Now it's there. Now I could put it over 1 now if I want, but still. What am I going to do to that? So the power goes
To the front.
to the front, so it's going to be times the 1 that's out here, right?
Yeah.
So I'm going to be left with?
-2u.
Very good. To -3. All right, and then from here, I'm going to clean it up. I'm going to put the u to the -3. I'm going to move that to the denominator. So in the denominator, it's now going to become positive, right? Yeah. So right near it's negative. So I'm going to have a -2 on top, and now it's going to be u to the +3 on the bottom. This stuff right here a whole lot easier than all the other limits and continuity that we did. Yeah. This is the reason why I say that calculus is a lot easier than the algebra. It really is. It's a new math, but everyone freaks out because that first unit. So let's rewrite C. I want you people to try and rewrite C first, and then I'll do it. Rewrite C, and then try to take the derivative. Uh-oh, miss them. Hold on, Brand. Hey, what did you? Yeah, change it to 0. Did you scroll down to the very bottom and hit save? Save and assign? You want me to go into your class and fix it? Class settings. Requirement and change that to 0. All attempts. And save and update or something, I think. Save and assign. Okay. I'm in here. Give me a minute, okay? I'll call you back. All right, give me 1 second. All right, what did we get? Very good. So we have 4s to the negative 5. That's negative 20. S to the negative. Ouch!
Oh, -6.
Very good. All right. And that turns into negative 20 over s to the positive 6 there.
Okay.
No worries. That's kind of why I had you guys try that one yourself. All right. Let's look at the next one. Hey, try it now. Hit refresh. Yeah. You should be able to just get into it now. I removed the whole thing. Okay. All right. I just removed the whole thing. Anyway, all right, find the second, third, and fourth derivatives. So, notation for derivatives. So we have single tick marks. So y prime means the first derivative. What's the first derivative of this one going to be? 6x squared, very good. 6x squared. Now, y double prime means that is the second derivative. So take the derivative of the derivative. Okay, so 12x and y triple prime is going to be the third derivative, which is just 12. Now, when we're talking about physics on this one right here, there's a reason for finding these things. So this is a function for position. This tells me my location at a certain time. So if I plug in an x, I'm looking for the y value at that time. That's going to give me my position given that time. My next one is going to be my velocity. So the first derivative is going to be velocity. That is my rate of change. That's how fast I'm going at that single point in time. The second derivative on this one is going to be acceleration. So, yes, we're going 45 miles an hour, but what is the rate of change of that? You know, Denny driving through that school zone, is he accelerating when he hit the kid, or is he decelerating like he was trying to hit his brakes, okay, before he hit the kid in that school zone?
Accelerate.
Okay? Is probably, so the rate of change, so is he increasing at an increasing rate? So he's doing 45 miles an hour, but the acceleration, is he keep going faster? Or is he going slower? Is he going to start going slower? But he's still, at that point, doing 45 miles an hour. But is the acceleration going down? So he was going faster, and then hit 45, and then he was, you know, the next second he's doing 40. Or he's going slower to faster. So is he still on an incline, like going up in speed? So was he start at 40 miles an hour, hit the kid at 45 miles an hour, and then the next second after, is he at 50 miles an hour? So that's going to be the acceleration. And jerk. It's the instantaneous force of what is happening at that current. So the pull right there at that certain. So it's kind of like when you see someone, I don't know, watching like Fast and Furious, everyone peels out, and all of a sudden they like jerk back at that single moment when it catches on. Yeah, that's a jerk. Find the second and third derivative of this. Now, this one is one that we already did. This one right here is a product rule. So for those people that decided to not come to class, you have to go find the product rule. So it is f prime g plus g prime f. This is my f, this is my g. So as you're doing these, I highly recommend labeling them like this, and then before you do anything, go off to the side. And so if f is 1 plus x squared, f prime would be 2x, very good. G is e to the x, g prime is e to the x. Now I'm going to go through and do the math for this one. So let's go ahead and put these together. So it says f prime g. So f prime is 2x times g, which is e to the x, plus g prime, e to the x, times f, which is 1 plus x squared. So this one right here would be considered my first derivative. So this would be my y prime. Okay, that's the first derivative. I want to take the second derivative, and I need to identify the parts of this. Is this right here the same as that? Say yes. It's the same thing. It's just the e to the x is on the front. Could it be the same if I just put it in the back?
Yeah.
Okay, this is like saying 3 times 5 is the same as 5 times 3. Okay, that's a property in multiplication. So it's the same thing. So I don't have to do this part when I do it again, because if I take a derivative of this whole thing of y prime, I have to do this piece, and right here, since I'm multiplying, I have 2x times e to the x. This is going to be a second product rule. This is going to be a second product rule here. It's a second one. So we're doing this product rule since we already did it for the derivative. Now the second derivative, I need to do it again. So right here, two derivatives. So for this one, it's going to say let's call it f and g. Because it's a 2x times e to the x. Those things are being multiplied together, and I have to take a derivative of that. So in blue, I'm going to say f is 2x, f prime is 2, g is e to the x, g prime is e to the x. Right? Okay. So all this right here in blue is going to have to do with this piece right here. So I'm going to say that my y double prime is, so if it's f prime g, so f prime is 2, g is e to the x, plus g prime, which is e to the x, f 2x. So that's this piece right here, right? But now, plus, what is the derivative of just this piece right here? Didn't we already do that once? We already did this once, because it's the same as what my first derivative is, right? So this piece right here just so happened to be the exact same as my y, and so my y prime is going to give me the same thing that I did right here. So the y prime, which would be 2x times e to the x plus e to the x, quantity 1 plus x squared. I could have done it again. You want me to rewrite it? Okay, here, how about this? This one, let's call this one F and this one G.
Okay, so you copy and paste.
Okay, it's F and G, right?
Yeah.
Okay, this is F and G. You notice it just so happened to be the same. F prime was
Oh, right.
2x times G, which was e to the x, plus G prime, which was e to the x, right?
Okay.
And times F, which was 1 plus x squared. So that is this piece right here. We're taking the derivative of this, which just so happened to be the same as my original where I went through and did that. So is that better to actually just rewrite it and do the whole thing over? Or instead of skipping a step? No?
Yeah, I think not better. It's just.
Yeah. And so we did this one again. And then we're going to have to do this again because we're going to have to look for the third derivative here in a moment.
Okay.
So before I get too far into this, let's go ahead and do any combining because that's going to make my life a whole lot easier here. So I'm going to have y double prime is equal to, let me see, so if I rearrange this, I have this one and this one right here, right?
Yes.
So that would give me 4x e to the x. So that combines those. All right, and that's going to leave me with, right here, that would give me, if I distribute this, this one's going to make, yeah, distribute this, see if that makes it a little bit better. Actually, I don't even have to distribute it. Do you know why I don't have to distribute it?
Why?
It's the same as what I had up here.
Okay.
Yeah, it's the same. I could, and that would give me, let's see what I get if I could. So that would give me e to the x, because if I distribute that, that's e to the x, and this is going to give me plus e to the x, yeah, x squared. Fat head's in the way. Bring down my plus 2 e to the x, and then this piece and this piece will add together, which would give me 3. Or x e to the x 3 plus 3 e to the x plus e, don't mess up, stop it, e to the x squared. So that's my second derivative. And we need to go to the third derivative. So if I was to use this right here and say that this is a physics problem, when I would plug in x, that would give me my position. If I plug in my x value into my first derivative, that would give me my velocity. That would give me my velocity, and if I want to consider it another way, like Danny doing miles per hour, the absolute value of velocity is your speed. It's like how fast you're really going. Absolute value, because if you have a negative velocity, what does that mean? Very good, perfect. You're going different direction. You're going backwards. Okay, positive velocity, you're still going forward. Okay, and the next derivative, where we're at right now for the second derivative, that would give me acceleration. That would tell me, when I plug in that x value, that's going to tell me that I am going to be, am I increasing in speed or am I decreasing in speed at that certain point? So am I still going faster if I'm building up speed, or am I starting to slow down? So I'm going to take this one right here, and I'm going to take it over to the next slide because I need some more room. And that was y double prime is equal to
4x
e to the x 3.
3 e to the x.
Okay, so where is my next product rules? I have a product rule right here, and I have a product rule right here, because these two are being multiplied together. Is there a second variable in there?
I'll get that.
Yeah, there's not a second variable, so that's why. That's why there's not a second variable, so I just gotta leave it alone. So I can go through and do these ones now. So now from here, let's call this F and this G. So F is for X, F prime is 4. G is e to the x, G prime is e to the x. So this is going to give me y triple prime, my third derivative, f prime 4 e to the x plus g prime e to the x, f, which is times 4x. Plus, what's the derivative of 3 e to the x? What's the derivative of e to the x?
E to the x.
E to the x, so it's going to be 3 e to the x. That one doesn't change. It's going to be 3 e to the x on that one. So that's 3 e to the x. And now I'm going to take a look at this piece right here. So again, and I'm going to change colors on this to make this one. So this one right here, I'm going to do here. I'm going to say that this is going to be my f and this is going to be my g. So f is e to the x. F prime is e to the x. G is, hold on. Start freaking out again. What'd you say? Yeah. Bless you, I think. Was that a sneeze? Maybe. I don't know. All right, so G is, there you go, x squared. And G prime is 2x. So I'm going to add this to my product plus, so that's plus right here, that's this plus, f prime, which is e to the x, f prime g, which is x squared, plus g prime, which is 2x times f, which is e to the x. All right, if this is a free response question, I would leave it alone right there. I really would. Now, let's go ahead and try to clean it up a little just so we can know where our anything that we could combine. Let's see. We have only one x squared, so that's going to give me y. Third derivative, that's going to be x squared e to the x. So that's there. No more squares. Now x the first. So I have a 2x e to the x and a 4x e to the x, which is going to give me 6x e to the x. Then I have 4 e to the x and a positive 3 e to the x, which is going to give me a positive 7 e to the x. All right, is this too crazy? Super crazy. So product rule is probably one of the rules that is actually going to be most beneficial for everything that we do. That's the one that you're going to end up using most often. Then we'll get into chain rule, but you'll hate me after that one. All right, how many more do we have? All right, we have just these two. So definition, acceleration. For an object, rectilinear motion, the distance s from the origin at time t is given by the function s, or s of t, which is my position. First derivative, d of s, d of t, is the velocity, okay? Velocity, so it's going to be another way of writing it. Instead of saying s prime, you could also refer to it as v equals. So that means that we're stating it is now no longer position s, it's now going to be v, which is velocity of t. So the velocity in terms of time. And then if I take a derivative of that again, gives me my acceleration. And I could call that one my y triple prime, or in this case, my s prime prime. This one right here would actually be acceleration. I can change it to a of t. So as defining the rate of change of the velocity with respect to time. So it's the second derivative off of that. Acceleration is the second derivative of distance with respect to time. So we're going to do a lot more that goes along with this, so I'm not, I know it sounds like I said a whole lot of stuff, but it's actually not too bad. It's just wrapping your mind around all these things. So we're going to go through this. It says the balls were propelled vertically upwards from the ground with an initial velocity. Ooh, velocity. What does that mean? Rate of change, right? So meters per second. So that's the first derivative. The height s of the ball above the ground is approximately s is equal, so that's going to give me my position function, where t is the number of seconds that elapse from the moment the ball is released. What is the velocity of the ball at time t? Okay, so let's take our position function. My position function is s of t is equal to negative 4.9 t squared plus 29.4 t. So if that's my position, yes, that's position. I'm going to take the derivative of the position. Derivative of the position, I said, is what's the first derivative? C, right? Derivative of the position is velocity. So my velocity, so this is going to be, I could call it s prime of t, or I can call it v of t. It means the same thing. That means the same thing. That's why I wanted to put these up here so you can see. It means the same thing here. So velocity. Now let's do the voodoo magic on this one. So voodoo magic, what do we get? Jenny, what do you get? What do you do to the exponent? Y what's up front, right? So that's gonna give me what? It's this number times what? Times 2, right? And so that's going to give you, okay, how about this? Rounded up 1. That's going to give you 50, right? So that's negative 10. Okay, and then how many times did you round it up? Twice, right? So there was 2 of them, so take back those 2. It's a mental math thing. So if you know what it's close to, you can go up and just how many times you multiplied that. So it's 0.1 for each one that you added to make it to 50, right? Or yeah, or 5.0. So yeah, it's just different tricks that you could try and do. So negative 9.8, and what do I do with my exponent? Subtract 1, so it's going to give me t. This is going to give me plus 29.4. Yes? Good? Okay. So there we go. So now that we have this, the question was asking, so this is my, for this first part, what is the velocity of the ball at time t? So that is going to be there. So whatever time it is, that's in terms of t. And then what is the velocity at 1 second? So it's asking for what is v of 1. If it's v of 1, what am I going to do with the 1? What am I going to do with that 1? I'm just going to plug it in, right? Replace every t with 1. So that's going to be negative 9.8 times 1 plus 29.4, which is going to give me a grand total of, was it 19? .6? Oh no, I'm trying to mental math. I can't mental math it. I'm still only halfway done with my coffee, so I can't mental math yet. I know everyone's trying to do this. Calculator should be out in front of them somewhere, hopefully. 19.6. I think everyone should have a calculator, right? Didn't I assign everyone a calculator? A special blue, like super high-end calculator?
It disappeared.
Oh, it disappeared, right? Okay. So it is 19.6. Now, what does that mean? In terms of this problem, I need to label my units. Is it meters per second? Right here, yes. So the height in meters, and where time is number of seconds. That's very good. See, I have to go back and read the problem to make sure that's what it is. So it is a velocity, so that's a rate of change. That is meters per second. Now the next one, so this is all question 1, I think. Yeah, that's question 1. Or A. Next one, let's take a look. This one's 2 or B. When will the ball reach its maximum height? What shape is this going to be?
Parabola.
It's a parabola, isn't it? Yeah. It's a parabola. If it's a parabola, I know it's going to, and it's a negative, right? It's opening down. So maximum height means it's going up, and at some point, it's no longer going to be going up anymore, is it? It's going to start going back down. So if I were to graph this, I would say that it's going to look like this, right? And what do you think? What do you think the tangent is right there? What do you think the slope of the tangent is at the very top?
0.
0. So that's going to be key. That step right there is going to be key for almost all the rest of this evening. At the very peak, my derivative is going to be 0, because that's when it's going to start going from increasing. So whenever it changes going from increasing to decreasing, it eventually has to hit 0. From it's positive, 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 now it's negative, negative, negative. So whenever it's changing from increasing to decreasing, it always will hit 0. So right here, I need to set what equal to 0 for this? Not y. Nope. Okay, think of which functions we're talking about here. I want the slope to be 0, right? So if I want the slope to be 0, which function am I going to use? Very good, the derivative. I want the derivative to be equal to 0. Okay, I want the derivative to equal 0. So on this one right here, I'm going to take my derivative, which is my v of t. So I want this to be equal to 0. So I'm going to say that 0 is equal to my negative 9.8 t plus 29.4. All right, so we subtract 29.4 and divide by negative 9.8, which is going to give me is it exactly 3? Yep. Is that 3? Yeah, it's 3.
Okay.
Positive 3. Now, t represents what? T is my what? Is it time? It's my time, right? Now, think of the limits on that. Okay, what can you not have when you're talking about time?
Negative time.
Negative. Can't have negative. No negative time. So if there's a negative time, that means that this happened outside of my interval that I'm allowed to have. So you have to check your work if you have something that is going to be like that. If you get an answer for a negative time, you can't really have negative time. Okay? So that's going to be real world problems have real world type of limits. No negative time, no negative distance. So t is equal to 3. So that means that it's going to be max is going to be at 3 seconds. This is all part B, or number 2, right? Now, I think this problem right here is always going to be question 2 on the free response exam. You're always going to have the same type of question, and it's always going to have a bunch of multiple parts. So you just have to go through item by item by item and just work them out. I know it looks like a long problem, but you have to just tackle a little piece at a time. Okay. What is the maximum height the ball reach? So, if it's asking for the maximum height, what am I talking about? What is it asking for?
Meters.
In meters, right? Okay, in meters. Is it asking me for the location?
Yes.
Yes.
Points.
Okay, so what function should I use?
Your normal.
My position function. That's important. The position function, that's my S function. So I want the Y value, which is going to give me my position. So I'm going to plug in 3 into my,
Your position.
which is the original, my S of T. So minus, was it 20?
29.
Okay, T?
Yeah,
That's a T, right?
yeah, I have.
Okay. All right, so now that's my position function, and now I want to plug in 3. So S of 3 . All right, what do we get?
100 negative 1.
Oh, it should be a plus sign. Sorry.
Oh, okay, that's a plus.
See? Alyssa, where were you on that one, huh?
I'm too
Huh?
tired.
Yeah.
I wanna
Someone
sleep.
doesn't have enough coffee yet either.
I don't drink coffee. I like a
See, that's what the problem is.
No.
Okay, there it is, right
I
there.
don't want bitter.
You don't have like
I
not
put
enough
condensed
coffee,
milk
so
in my coffee, so it
Huh?
makes me sleepy either way. I put condensed milk in my coffee.
puts a sprinkle a little crack in there. You know, get like that full meth, that kick, the rage. Okay, or just add some creatine to my coffee.
It lasts so long.
I've actually done that before. Put creatine in my coffee.
What?
Yeah, it's nasty, but guess what? You're like, I need the coffee. I know, right? So might as well eat it with a spoon. But since I drink coffee with a straw, start for the bottom. There we go.
There's 44.
And chunky. All right, what do we get?
44.1 meters.
S. I'm sorry. Yeah. F. Why did I F that? S of 3 is,
Right.
and this is going to be the height, right?
Yes.
How high is it up there? Okay, so if I was writing notes, I would say, okay, I need to make sure I know this one right here. I had to go find the position, so if I'm looking for the position at a time, like, I need to go to my first function. That's going to be the position function. So there's that one, maximum height. What is the acceleration of the ball at any time t? All right. So we have velocity. This is c, and then we're going to do d, which is acceleration. So we said that s prime of t, which is the same as velocity of t, was going to be a negative 9.8 t plus 29.4. Now, the next derivative, so the derivative of the derivative, okay, so this is going to be this, and I'm going to show you what all the different ways we could actually write this. So if the derivative is s prime, the derivative of the derivative would give me s double prime of t, which is the same as saying the velocity. I'm taking the derivative of the velocity, right? So that's going to be my v prime of t, which also is acceleration, isn't it? So that would say the acceleration of t. All those mean the exact same thing. They all mean the exact same thing. So when I go ahead and do the math, I'm going to come up with negative 9.8. Anyone take physics already?
Yeah.
So what is negative 9.8? That sounds important there. Gravity. Very good. That is gravity. Gravity is a constant acceleration. It's always pulling down, right? So we have a negative 9.8 gravity pulling it down for this one. And what are my units on this one? It's still meters, right? Meters per second squared. Per second. Acceleration is always meters per second per second. Does that make sense, or is that nonsense? Okay. All right, so right here we have acceleration at time. How long does it take? How long is the ball in the air? How long is the ball in the air? So I have to think about this. Am I looking for position? Am I looking for velocity? I'm looking for time, right? But which function am I going to be using? It's going to be position. It's good. Yes. So if I think about it, if I kick a ball, my starting time would be 0.
But once you put your feet on it,
Yeah, it's going up from that point. And so what else do I want to find?
it's endpoint?
Endpoint, right? My endpoint. And my endpoint is when it also equals 0.
So you find them.
I want it to be my position function, right? I want my position, so the height equal to 0. And it should happen 2 times. At the very beginning and at the end, right?
Yeah.
So this is going to be 5. Or question, what's D? E.
Yes.
E. There you go. E. So my position function, S of t, was negative negative 4.9 t squared plus 29.4 t. And I want that to equal 0. Because position is going to give me my height, and I want my height to be equal to 0. So anytime that you're going to have a problem like this, any physics problems that you want it to be on the ground, you want to know when it goes flat. I want my position to go 0. That's when it hits the ground. All the time. Position to equal 0. Goes flat. So set this equals 0. I'm going to look at that problem. I'm going to say F that. I'm going to say F that. Can you factor anything out of it? Possibly. Did you at any point take 29.4 and divide it by 4.9?
Yeah.
You never did? I know there's a t in it at least.
-6.
So you say there's a -6 is a common factor, right?
Yeah.
-6t? Or you're saying that I could take out a -4.9
Yeah, you can take out -4.9.
t.
Yeah, you can.
So a common factor is right there is -4.9 t because it goes in evenly to this, right?
Yes.
It goes in evenly to this, so that's going to leave me with t plus 6 equals 0. And I'm going to show you how to do this one on the calculator also. Because if you're not solid with your factoring, yeah, this is going to be super hard. So set each one equal to 0. So zero product rule, my favorite rule in math. 0 equals -4.9t. Divide by -4.9. So t is equal to 0. So didn't we already state that at the very beginning, before I kick this ball, it's going to be on the ground, right? It's starting on the ground.
Is that T?
That's a t. Sorry.
Oh, I thought it was Z.
I know. I cross my t's like weird. So there we go. Okay, so t is equal to 0. So that's my starting point because I knew it started on the ground at the very beginning. The next one is going to be ooh, do you know what I messed up on? I factor out a negative. I factor out a negative. Since I factor out a negative, this positive now turns to a negative. There we go. So plus 6. So 6 is equal to t. So how long did the ball stay in the air? 6 seconds. Now I'm going to show you how to do this in the calculator, and it's going to help you out often. For those people that bring their calculators to class or even take them out during class, how dare you? How dare you, the teacher, ask me to take out my calculator? All right. I'm just going to go scratch pad here. I'm going to put in my original function, which was -4.9 x squared. Very good. Plus,
29x.
there you go. So I'm going to hit enter. Bam. So there's my function. Are you guys ready to take notes on the simple steps here? Okay, you ready? So I'm hoping you have this in the calculator right now. Huh? You left it in your car? How dare you? You live in your car? Is it the car with no bumper? Bruh, go get a calculator. Trust me, I feel your pain. When I was in high school, I lived in my truck. Yeah, because I was actually homeless, but still. I know what it's like. Just leave everything in the vehicle. Leave it all there. All right, so let's go ahead. Menu. And I'm going to, I can do trace or analyze graph. So if I go to trace, I could actually just trace it to go look to see where things are. Or option 6, I can go analyze graph. And what am I looking for when I'm analyzing graph? Nope. You could do maximum too, but that would help you with these things. Because when we were looking for the maximum, right, that would have helped me there. So, but in this one, I'm looking for zeros.
Oh, interesting.
Yeah, and look at option 5 here. dy dx means I'm taking the derivative.
Oh.
This will actually find the derivative for me also. So, it's going to say lower bound. That means you're going to move this dotted line to the left of wherever you think it's crossing the x-axis. Okay, I'm going to click OK or hit enter right here, hit enter. And now it changes to upper bound and just trace it over. So my t equals 0 right here, right? Yes? Okay, so we already knew that one. Now let's do my other one. So menu, analyze graph, 0. Go over here to the left. There we go. There's my other 0, where t equals 6. What do you mean?
You use analyze graph.
No, I didn't. I used 0. Menu, analyze graph, 0. There we go. Looking for zeros. And could we have found maximum? Yeah. Maximum, I know the maximum is somewhere between here and here. There it is. We could have done that too, right? That could have given me that, but then I wouldn't have had the opportunity to do the derivative equal to 0, the slope equals 0. Because that's normally when you're going to have to do that the most, is my slope equal to 0. All right, and watch this. I'm going to hit tab, and I'm going to put the equation of the derivative in there now for my second one. So that's going to be negative 9.8x plus 29.4. There we go. So I have this here. Let me change out my window. I don't like this window. Menu, window, window settings, and X. Let's only go negative 10. Negative 10. That's as far as I need to go. Positive 10. Y min. I don't need to go below the line very much, but I do need to go up. So, yeah, 60 is okay. So I'm already knowing what the graph is, so I'm just changing it so I have just a better view. There we go. There you go. So if you notice right here, this is the graph of the derivative. So the derivative is equal to 0 right here, right? At t equals 3, right? It's equal to 0 at this point. So from the left side of my graph all the way to this point, isn't all this over here positive? Because isn't all this right here on my blue line to the right here, it's all increasing, isn't it? So it's going up, it's increasing. There is a positive slope. So that's why this line right here is positive to this point. And then down here, so right here it changes. It is now going down, right? So my slope is now negative, right? It's all going down. So that's why down here, from 3, everything below here is a negative value. So those are all negative slopes. And let's go back there. So now we solve 5. What is the velocity of the ball upon impact? Ooh. Velocity. Do we know when it hits the ground? When does it hit the ground? 6 seconds. So I know that the velocity at 6 seconds is what I'm trying to find. So the formula for the velocity, so v of t was negative 9.8 t plus 29.4. So velocity, when it goes splat, I'll let you guys do the math normally, and then I'll show you a nice way or a simple way to try to do this also. Is that what you came up with? Okay. Now, what does that mean? I gotta like put it in words now. What does that mean? It's going down. Velocity is going down, right?
Yeah.
So it's going down, so that means that my velocity, so if it's positive, my velocity is going, it's still going up. If it's negative, it is heading. So it went down and it went splat, right?
Yeah.
This is hitting the ground. Okay? Now, but give me units on this one now. So it goes splat. So this is going to be V of 6. So it's traveling 29.4 meters per second when it hits the ground. The negative out front means it is going down, right? It's going down, it's hitting the ground at that time. That's important. If it was going up, it would hit the roof. Okay? Remember, I said it a little bit ago, absolute value of this is my speed. So it's always going to be a positive. Speed is going to be a positive. You can't have a negative speed. Now, I'm going to show you in my calculator, because I love these calculators because they're super, super smart. So, see right here where it says vars? Right here, vars. Which function am I plugging this into? The second function, right? Because I put them both in there. I put my original function, and then I put my velocity, right? Okay, click that one. And I'm trying to plug in 6, right? Okay, could I have done that from my first one too?
Yeah.
Vars, first function. So we knew the maximum was at 3, right? Could I find the height then? And I know that it also goes splat at 6. Vars F1 of 6. So just using vars saves you a whole lot of time from having to plug it in every single time in evaluating each one of these. So let's see, menu, calculus, Okay. What was my original function? Negative what?
Negative
Or
4.9
9x
squared
squared.
plus 29.
Because I know when t equals 3, right? T equals 3, my slope was 0, wasn't it?
Yes.
So I can numerically do the derivative on this calculator. So I put my original function in, and I, what?
Where was the zero?
Menu?
Oh, it's in menu.
What class are we taking?
Calculus.
Calculus. There we go.
Oh, numerical.
Add a point. So those are always good. And I use these other ones for my other classes. So I don't know if you want to use those, but anyway. Where are we at now? So we got that one.
We're at G now.
G,
What is the total distance traveled?
total distance
Meters.
traveled. Which function is that?
First one.
Position, right? Okay, and so I want position. Okay, so distance traveled.
600.
Okay, so now if I plug in 6, what did I end up getting when I plugged in 6? When I plugged in 6, I ended up getting 0, right? So the distance is how far I'm going. Okay, so let's see, meters. So if I'm doing my graph, let's see what the graph is. Now, from here to here would be the best way to do it. And then I know it's going to be the same from here to here, right?
88.2.
Okay, so I want to go from here to here, so it's going 44.1 up,
And it should
and then it's going down another 44.1. So the total distance traveled, because it changes here from going up to going down, that's why I got 0 over here in my position. So I take this one, and I know it's 44.1 up, and it's also going 44.1 down, so it's 88.2. So my distance travel is going to be 88.2 what?
meters.
There we go. So my distance travel, this one's G, right?
Yeah, it's G.
Now, by talking through those, talk to yourself going through these. What is it I'm asking for? What is it looking for? What position, what function, what equation do I need to plug in for each one of these? Don't be afraid to ask questions if you're struggling on these, because we're just now starting to do these things. All right, does that make sense? Yes? A lot of things, right? Step by step, a lot of steps. But each step, it's not that hard. You just need to identify what it is we're looking for. Calculus, AP Calculus is a puzzle. Everything works out nice. There is a puzzle piece, and it fits just right. In normal real world stuff, it doesn't. But AP Calculus, the way that it works out is it's always going to look nice and pretty. It's going to simplify to be something easier, okay? If you get something ridiculous, crazy type of answer, then you might have made a mistake somewhere, okay? So, make sure you all like, share, and subscribe. Hit that notification button and support my channel. Buy stuff from my merch store. I got new beanies at my merch store. Yeah.